Okay, page 2, number 15. Factor completely, check for GCF. So as I look across here, and if I think about all my different factoring, this one stands out because it has 4 terms. And you can either do it by grouping where you underline, or you can do the box. And because I don't have a lot of room here, I'm going to do all these down here. So I'm going to go ahead and I'll number it. And I'm going to go ahead and fix my box for it. I think you can still see all of it. So I've got 4a cubed, positive 10a squared, negative 10a, and negative 25. So the GCF here is 2, which leaves me a 2. 2 times 2 is 4, and 2 times 5 is 10. They have 2 a's alike. Leave me an a and no a's. I'm going to go ahead and put my plus there. Now if I take 2 away from 2a away from negative 10a's factor tree, I'm left a negative 5. And then we can check, negative 5 times positive 5 is my negative 25. So my 2 binomials, and I'll just come back up here and put those, are the 2a plus 5, doesn't matter which one you start with, and the 2a squared minus the 5. Number 16, it's a trinomial, but the first thing that stands out to me is I see I have a GCF of 2. So I will go ahead and take the 2 out, and I have v squared plus 10v plus 25. Now, I recognize it as a perfect square trinomial. You may not, and go on and do it with a x box. I will go ahead and put my 2 and my 2 binomials here and do the x box below it. So the top of my x, now remember, I'm only factoring this part right here, will be these 2 multiplied together, 25v squared, and a 10v here. Okay, I need factors of 25 that will give me a 10. So my factors of 25 are 1 and 25, or 5 and 5, and that's it. And those 2 that will add to 10 are the 2 5s. So I've got 5v and 5v. So we'll do the box. Now remember, we're factoring the v squared plus 10v plus 25. So I'm going to put my v squared here, my 25 here, and then my 2 5v's here. GCF, v, that leaves me a v here and a positive 5. When you take the v away from the 5v, you also have a positive 5, and then these check to give you the positive 25. So notice that the 2 factors are the v plus 5 and the v plus 5. Now that is a perfect square trinomial, and if you recognize it, you could have gone straight to the answer, but usually it just takes more experience to recognize those. Number 17, we've got a trinomial. I don't see any GCF, so let's do X box. Number 17. Let's see, I'm going to, let me slide it up just a little bit so we can at least get our numbers. So our X is going to have the 3m squared times the negative 10n squared, which is negative 30m squared n squared. And the negative 29mn in the bottom. Now I need factors of negative 30, and I'm looking for negative 29. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Well, if they need to add up to a negative 29, and we're talking about positive negative, it's got to be the 1 and the 30. Now I'm going to go ahead and put the 1m in, and the 30m in. Now let's figure out the way the signs go. If these 2 are going to have to multiply to be negative, one's got to be negative. But to add to be a negative, this is going to have to be your negative and this one the positive. And I kind of ran into my X, but I believe you can see it. So in our box, we'll go back to the top. Our trinomial is 3m squared. And then the minus 10n squared at the end. We're replacing the negative 29mn with the positive 1mn and the negative 30mn. GCF, they have an m alike. We have 3m left, and we have positive 1n or just n, if you want to do it that way. If you take 3m away from negative 30mn, 3 times negative 10 is 30. And if you take the m away, you still have an n left in the factor tree. And then we can check. negative 10n times n is negative 10n squared. So our two binomials, we'll go back up here and write them, are the 3m plus n and the m minus 10n. Number 18. Okay. A squared plus 11a plus 28. That's just a trinomial. I'll go ahead and, no, there's no GCF, so I'll go ahead and put my two binomials. And let's make the x. Okay, together we have 28a squared and 11a. Now factors of 28, I've got 1 times 28, I've got 2 times 14, and I've got 4 times 7. And I need them to add to 11. Well, because everything's positive, then the positive 4 and 7 is exactly what I need. So we'll make the box. You want to go back to your original problem to get the first and last term. So we've got a squared, and we've got 28, and then we're going to replace the 11a with the 4a and the 7a. Okay, the GCF across the top is a, which leaves me an a here and a 4 here. If I take a away from 7a, I have a 7, that's positive, and I can check it. 7 times 4 is the positive 28. So my two binomials are a plus 4 and a plus 7. Number 19. Simplify. You add and subtract radicals just like you do variables. So we'll put our like terms together. Well, I see some square root of 3's. So I have 2 square root of 3 plus 2 square root of 3, which gives me 4 square root of 3's. Minus 3 will give me 1 square root of 3, or you can just say square root of 3. And then we'll bring down our minus 2 square root of 6. I can't put those together because the radicands are not the same. That's all I can do to it. Number 20. The easiest way to simplify when you have two radicals multiplied together is multiply first. So let's do the rational outside. So I've got negative 12, and on the inside I have 200. I have 5 x's. Now I need the factor tree of 200. I think I can do that right here. 2 went, 2 goes again, 2 goes again, and 5 goes 5 times. So we have a pair of 2's and a pair of 5's. So I'm going to bring down my negative 12. Underneath my square root, I have my 200, which is now 2 squared, times 2 times 5 squared. And then my x to the 5th will break into x squared times x times. Now my perfect squares are the 4, the 25, the x squared, and the x squared. So we can already see what's going to be left underneath. And I'm kind of scrunched up here, but I think I can do it. I'm going to just kind of come over this way. So I've got my negative 12 on the outside. Don't want to forget him. We're going to bring the square root of 4 outside, which is 2. The square root of 5, 25, which is the 5. And then square root of x squared and the square root of x squared. And then that leaves me a 2x on the inside. So I'm kind of going around, but I'm going to come up here. And so I've got negative 12 times 2 and 5. And the easiest way to me is do the 10 times the negative 12, which is negative 120. And I have x squared. And then inside I have a 2x.